Hi, welcome to AI Shorts, the show where we talk about the intersection of machine learning and product management. Today I want to round out our focus on data and talk about data types and storage. It's essential to have a well-rounded understanding of data to be an ML practitioner, so let's dive in. Let's start by doing a quick run-through of the primary data types in Python, since it's the most popular machine learning language. Integer. This data type is used to represent positive and negative whole numbers. Float. This data type is used to represent decimal numbers. Boolean. This data type is used to represent logical values, such as true or false. String. This data type is used to represent text data. List. This data type is used to represent a collection of values. Tuple. This data type is similar to a list, but the values can't be modified once they've been created. Dictionary. This data type is used to represent a set of key value pairs. Set. This data type is used to represent a collection of unique values. Now that you know the different data types, let's talk about how data is stored. Data is stored in databases, and the choice of database depends on the particular needs of the project, such as data structure, scalability, performance, and security. The two databases that you really need to understand are relational and NoSQL. When you think about relational databases, think about how data is stored in rows and columns in a spreadsheet. That's a relational database. They're used for handling structured data. NoSQL databases can handle unstructured data and store the data in documents rather than relational tables, where documents are linked via key value pairs. There are many types of NoSQL databases, but document-oriented and key value pair databases are the types that you should be aware of. There are more database types used for machine learning, such as distributed databases and time series databases, which you can read more about online. Historically, companies have used data warehouses for storage. Data warehouses are optimized for fast querying, analysis, and reporting. They typically store data in a structured format using a predefined schema. So when you hear the word data warehouse, think relational database. Some examples of cloud data warehouses include AWS Redshift and GCP BigQuery. These days, many companies store their data in data lakes for machine learning. Data lakes enable storing, managing, and analyzing vast amounts of data without requiring a predefined schema or structure. Examples of popular data lakes include AWS S3 and Google Cloud Storage. Finally, there's a relatively new idea of the data lakehouse. This brings the benefits of the data warehouse, such as data quality, schema enforcement, and query performance, to the data lake, while also retaining the flexibility and cost-effectiveness of a data lake. Examples include Delta Lake and Databricks, both which are built on top of Apache Spark. If you're new to databases, the concepts of data warehouses, data lakes, and data lakehouses can be confusing. However, as you work with new machine learning problems, research what databases are most appropriate for your machine learning problem. Over time, you'll become comfortable with these concepts and they'll seem second nature to you. As a product manager, it's essential to understand differences and trade-offs between databases when designing a new system with your engineers. Having a solid understanding of databases will help you ask the right questions to your engineers and help guide you to the best solution. I'll post links to all the topics and concepts that we discussed today in the video description below. I hope this video has inspired you to dig deeper into databases and data types, and I'll see you next week.